today's topic is development of surfaces. And when we think of the development, we are required to consider a few objects and go for the development, that means the true shape of the lateral surface of that object. For example, if we consider some square prism, then this square prism is having in all 6 faces, and those 6 faces, if we expand them, can be shown roughly, say in this manner, because there will be 4 rectangles which will go in the lateral surface, and there will be the top surface as well as the bottom surface. It is actually, you are going to draw this figure on paper and then you are going to cut it and form the object, which is going to be something similar to the box. Similarly, if we think of the cylinder, then that cylinder can be cut along any of the generator, and obviously the development that we could be getting, that is the true shape of the lateral surface of it, it is again going to be a rectangle whose dimensions will be pi d and the height will be the height of the cylinder. Of course, the top is going to be a circle and bottom is also a circle. This could be considered as the development of a cylinder. If we think of cone, and if we open it up, then we are going to get some sector of the circle, such that this length of the arc, this will be equal to pi d, but that diameter will corresponding to the diameter of the base of the cone. Whereas for the sector, this particular length is going to be the slant height of that particular cone. We are required to find out this internal angle, which can be very easily found out, because this h, that is the slant height, can be considered as the radius of this arc, and we can have a formula like if this angle is theta, then we can very well write it as theta into h. Of course, in case of the radians that we are calculating, will be equal to 2 pi d, and then theta can be calculated because it is going to be 2 pi into d upon h, where h is the slant height. Using this formula, we can calculate theta and draw this arc. Of course, the base circle is to be shown separately, but when we think of the lateral surface only, then in case of the lateral surfaces, we are not supposed to show the top and bottom. Even in case of square prism, that is not required. Even in case of cone, it is not required. We are going to talk about only the lateral surface, and then the development will be only the rectangle in case of square prism, again a rectangle in case of the cylinder, and only the sector in case of the cone. In case of square prism, as we are going to have these generators which are forming the edges, these edges are to be shown fully by the dark lines, whereas in case of cylinder, these internal generators which are not forming any edges of the surface, they need not be shown. Only the end generator, or the generator at which we are going to cut the cylinder, that should be visible, that is the end generator. If we proceed to pyramids, say a triangular pyramid, then the development is going to be the true shape of the three triangles, which are under consideration, and also the internal edges are to be shown. So compared to our previous problems, these development problems, they will be definitely easier. Let us take one problem where we are required to draw the development of a square prism. The problem statement is, you can take down the problem statement. A square prism having side of base 50 millimeters and height 70 millimeters is resting on its base in HP, such that the sides of base are equally inclined to VP. Draw the development. If the same prism is cut by an auxiliary inclined plane, making 35 degrees with HP, passing through point on axis 25 mm from top surface, draw the development of the lateral surface, of the cut portion, showing three views of the object, Now the top view is going to be a square which is to be drawn at 45 degrees. Now to draw that square at 45 degrees, it will be better if we construct the square first, then take the radius by finding the center and draw that circle or mark the points so that the square can be drawn at 45 degrees of side 50. So the construction is to be shown separately instead of drawing it directly. So the square is drawn at in the top view such that sides of the square are equally inclined to VP. That means they should be making 45 degrees with XY line. It is resting on its base, so the top view will remain a square, and front view is to be drawn. For that we are required to shift all the points by drawing the perpendicular to xy, that is the projectors. First take the points of the base, and height is given to us as, how much is the height? 70. So we can mark the height in the elevation. And even the elevation of this square prism can be completed. So we don't find any difficulty in drawing this part. But we are required to also name these, and afterwards as we are going to cut it, we will be looking for the side view of this square prism, because we are asked to draw the 3 views of this particular square prism. So it will be better if we initially construct the side view, though in every problem of development it may not be required. So the problem of development can be considered as the problem of projections of solid along with the development. So to draw the side view, it will be the usual procedure to draw some vertical line, and then we are required to transfer the points from the top view. Wherever that vertical line is drawn, it is intersecting xy line at a particular point. That should be considered as a center, and we should be rotating all these points to obtain the side view. Better if we draw it by arcs. This is going to be more accurate procedure than drawing the 45 degrees line and transferring the points to the side view. So as we get all the points in the side view for the base plane, we can very well complete the side view. As we are drawing it by the first angle method of projection, this is going to be the left hand side view. And now to draw the development, we will be using the same xy line in the extended form. There could be some distance of separation which we can take, say generally 20 millimeters or so. No hard and fast rule for it. And we know that the development is going to be a rectangle. So to draw that development, I have extended the xy line as well as the top. Let us first of all name it. Base, as usual, I am going to name it as ABCD. So these points will be A dash, B dash and D dash and C dash, whereas the corresponding points of top are to be named as 1, 2, 3, 4. So this is 1 dash, 2 dash and 4 dash. This is 3 dash. Whereas in top view they are going to coincide. So generator A1 will be seen as point, similarly B2 is a point, C3 is a point, and D4 is also seen as a point view. In the side view we can transfer the points. Side view is also named as if it is elevation. So this is 1 dash, 2 dash, 1 dash, then this is the base point is A dash and the top point will be 1 dash. This is B dash, corresponding top point is 2 dash. This is C dash, 3 dash, and this is going to be D dash and 4 dash. They might ask you as from where the particular lateral surface is to be opened. They might say that it is going to be the right generator in the front view, that is in this case C, or the generator which is towards the observer, in this case it is generator B2, will be the edge from which we are required to open the lateral surface. Let us consider that it is given to us in the problem that the lateral surface should be drawn, or the development should be drawn by cutting the prism from the generator which is closer to the observer. Being first angle method of projection, observer will be looking from this direction. This is the direction of viewing to obtain the front view. And so B2 generator will be towards the observer. We are required to open the lateral surface from generator B2. As we have already stated, it is going to be the true shape of each of the lateral face that we have. We know that these are all going to measure 50 millimeters by 70 millimeters, but as a procedure we will be always transferring the distances using compass. So I have drawn BC, then it will be CD that is marked, then it will be DA, and then finally AB. And so we can complete first of all the naming. So this is generator C, D, A, and again B. So the end generator will be repeated, and the development of the lateral surface will be now 4 rectangles, each of side 50 by 70. And all the edges are shown full and final. That was the first part of the problem. Of course, dimensioning is also required. We can show the height of the prism, which is 70 millimeters, and of course the side of the square, as well as the angle made by the side. Both are to be shown because it was given in the problem statement itself. So the side 50 millimeters. So we will be showing the side of the square as 50 millimeters, and even this angle as 45 degrees. So we get first of all 3 views and then the development. This was first part of the problem. When the object is intact, it is not cut. Development should be simply named, dimensioning is not required unless it is a problem of cylinder or cone. This is how the solution will appear. The projections, though in this case are not very important as such, very simple and straightforward type of projections. Now let us proceed with the second part, that is the section of this particular solid. For that section, we are given that the auxiliary inclined plane is passing through a point on the axis 25 millimeters point on the axis, which is 25 millimeters from the top surface. So we can mark that point. And to show the angle, we will be always requiring some reference of horizontal line, because we cannot place the protractor otherwise, and then draw that angle. Now the question is whether the angle should be drawn in this manner, 40 degrees, or whether it should be drawn in this way. Remember that as we are going to see the side view from left hand side, the cut surface should be visible, and if we cut it in this manner, if the section plane is like this, then only from left we can see the cut surface. If we cut it in this way, then the left surface will not be seen, the cut surface will not be seen. So mark that angle of 40 degrees. And show the section. Section is always shown by the center line, cutting plane. We'll retain the portion on which the object is resting. The ends are to be darkened, they are thicker in case of section plane, and the arrows which we are going to draw perpendicular to the section plane, those should be actually pointing the portion which is to be retained. So when we take the section and show arrows in this manner, it means that the lower portion is retained and the upper portion is removed. This will subsequently remove the part which is the portion above the section plane. So this portion is removed. Of course, when we draw it in the exam, we will not be given the problem in 2 steps, and while drawing only we should be careful as which portion is to be darkened and which portion is to be removed. Here, as we have solved the first problem, we already have the dark figure with us, so we will have to erase some portion. Now to complete the views, this particular top is cut at a particular point over here, so we are required to transfer that point to the top view. You can observe that generator 2, 3 and or rather the sides of the top 2 dash, 3 dash and 3 dash, 4 dash are cut. So the corresponding points can be marked in the top view, which will be respectively the points on side 2, 3 and 3, 4. Whereas all other generators, they are directly cut. So these are the remaining 3 points. So if the section is to be shown in the top view, then this is the portion which is cut, whereas this small triangle of the top surface will be retained. Section lines are required, but now as the object itself has got sides making 45 degrees, probably we will be drawing the section lines at some other angle. Generally the section lines are to be drawn at 45 degrees. In this case, if we draw it at 45 degrees, those will appear to be lines parallel to the sides of the square, and instead of that we will be choosing some other angle uniformly, showing the section lines. So the top view will show us the section. Front view, we can see the cutting plane, and what we are required to complete now is the side view. So once we complete the sectioning, we will proceed to draw the top view, draw the side view, left hand side view. In the left hand side view, it will be easier to mark the points because we can directly see the intersection with generator A1. That point can be directly transferred. Same is the case with generators B2 and D4. We directly have a point, it can be transferred. And the question remains about the points on 2 dash 3 dash and 3 dash 4 dash, because those 2 points we cannot transfer, because we cannot get the intersection point in the side view. Those are the 2 points which are to be transferred from the top view. In top view we have these 2 points which can be taken to the side view through rotation, and we can mark the points at the top. So let us first of all mark the points which we already know. So point on generator B and D, and point on generator corresponding to A. So these points are transferred, and then I am taking even the projections from the top view, so that these 2 points can be taken to the side view. Same procedure, you are required to transfer the points through the arc, take the correct distance, so 1 point on 3-4 is transferred, and the other point on 2-3 is transferred. These points are to be taken to the top surface. So the points will be, this is point on generator D4, this is point on generator B2, this will be point on generator A1, and these 2 points of the top. So in the side view the section will be seen in this manner. No need of naming these points. Even if you name them as PQRS, that could be okay. And now this portion of generator A1 is removed. Same is the case with generator B2. Some portion is removed. Generator D4, part of it is removed. And so far as generators, or rather the edges of the top, that is 1, 2 is completely removed, and 3, 4 is partially removed. So obviously there is no portion over here of the top. Same is the case on the right hand side. So we will be left with only this part. This portion of A1 is still dark. In the section we don't show the hidden details, otherwise this portion of C3 would have appeared as the dotted line, hidden part. In the side view we can draw the section lines at 45 degrees, and so the section should be shown. If we would have cut it other way around, then this entire cut portion would have been behind, and then this entire portion will appear as the hidden detail, and the question remains as how are we going to hatch it. So even if it is not mentioned in the problem, when they say that draw 3 views or draw left hand side view, front view should be cut in such a manner that the cut portion should be visible. So this was a standard problem of sections of solids, rather much easier than any other problem. Now proceed to complete the development. For development now we are required to transfer the points, because the generators are cut. We already have the heights of these points which can be now taken further. So observe that I have transferred all the points. This was the height of point on A1, so I can mark that point. This is the level at which B2 and D4 are cut, so I can mark the points on B2 as well as D4. So we have obtained these points. Generator C3 was not at all cut. Generator C3 is not cut by the cutting plane. But we also have points on 2, 3 and 3, 4. Now we want their true distances, and those true distances are to be taken from the top view. In the top view, we can measure this much distance on the edge 2, 3 and then transfer it on the development. Remember that in this case we are required to always consider where the true length is seen. You could have taken the point from the front view if 2 dash 3 dash would have been the true length in the front view. So take distance from 2 towards 3 and then on the development mark it from 2 towards 3. Similarly, the same should be the distance due to the symmetry, that is from 4 towards 3. So we can mark the 2 points. And so these points are to be connected to complete the development of the lateral surface. This will be the development of the lateral surface. Of course, faces AB21 will no longer remain the rectangular face. So AB21, this portion of the rectangular surface has been removed. So you will have to draw it faint. And so these things will not be there in the final development. Generator C3 will appear full and all other generators are appearing in some parts. That will complete the development of the cut solid. As we are erasing it afterwards, we are required to even finalize these lines. In the exam also, even if you erase some portion, do not forget to maintain the continuity afterwards. That is essential. Generally, we will not be using the eraser at all. This will be the development of the lateral surface. So we have 3 views, and then we also have the development. Next problem. Draw development of a cylinder. Draw development of a cylinder having diameter 60 millimeters, having diameter 60 millimeters and height 80 millimeters and height 80 millimeters, which is having a square hole, which is having a square hole whose faces are equally inclined, whose faces are equally inclined to horizontal plane, whose faces are equally inclined to horizontal plane, axis bisecting the axis of the cylinder, axis bisecting the axis of the cylinder, and axis of the hole is perpendicular to vertical plane. It is also cut by an auxiliary inclined plane, making 30 degrees with HP, passing through point on axis 10 millimeters from top, passing through point on axis 10 millimeters from the top. Draw the development of the lateral surface. Draw the development of the lateral surface. Now, as it is resting on its base in HP, or even if it is not mentioned, for the development problem we can place on its base in HP, because we are not required to draw any other view than the front view and the top view. So we will be drawing the circle in the top view of diameter 60 and then dividing that circle into 12 parts. This will be the easiest way, as I am showing you, rather than using the arcs. The best use of 30-60 set square as well as 45 degrees set square should be made. So we are required to transfer these points, the 12 generators, to the front view. All this should be simply the construction. We need not draw any dark line. Observe that when I had drawn the circle, immediately I had drawn the axis, that is the center lines of it. The height of the cylinder was 80 millimeters. So we can mark the height. And then all the generators should be drawn up to that height. Only the end generator is going to be the dark one. All other generators, they will be simply the construction lines. And so the front view of this cylinder will be a rectangle. First of all, let us draw that section plane which is passing through point on axis 10 mm from top and is making an angle of 30 degrees with HP. So that cutting plane can be marked. Unless otherwise mentioned, we are not going to draw the side view or any other details. Generally that will not be asked in the exam. Combination type of problem is not there. We will be asked only the development or only an independent problem for the section. So the section plane also has been shown. We have started our job without naming it. We will name it at the appropriate time because I am not yet showing any details. The ends of the section plane should be made thicker. And the arrows are to be drawn. To indicate as which portion is retained. Another information that is given to us is it contains a square hole whose axis is bisecting the axis of the cylinder, and that axis is also perpendicular to VP. That means the square hole will be cut in this manner. So it will be seen as square in the front view. So let us mark the midpoint of the cylinder, the axis, the height of the cylinder, where we are required to show the square in the front view. The side of the square hole is, I suppose, not mentioned in the problem. So let us take it as 30 millimeters so that we can get the appropriate view. And to construct that square whose faces are equally inclined to HP, if the face is equally inclined to HP, then it will be making 45 degrees in the elevation. So here we are required to again draw a square in this manner, and to draw the square of side 30 we are required to construct it separately, because we will be looking for the length of the diagonal, which you can calculate but you should not, because this being a paper of graphics, everything should be found out through the drawing technique only. Unless otherwise required, calculator is not to be used. There is only one problem, rather two types of problems where the calculator should be used. One of them is the current problem, that is the cylinder. To find out the circumference of the cylinder, we will be using the calculator. And even in case of cone, to find angle theta, the calculator should be used. Otherwise, we will be having the construction. So here I have constructed a square of side 30. find out, take the length half the diameter, half the diagonal, and then you can cut the points so that the square of side 40 can be drawn in the front view. So front view can now be completed. It has a square hole whose faces are equally inclined to horizontal plane, so they will be making 45 degrees with XY in the elevation. Axis is perpendicular to VP, so axis will be seen as point, and we are required to draw development of this cylinder. For the development, you are required to extend XY line as well as the height of the cylinder. We will take some distance from the front view as a separation distance, and from there we are required to draw the development, which will be a rectangle. So the calculation is to be made. How much is the value of pi d? It is 188.5, and so we will have to mark the distance 188.5. So it is 188.5, and we get the development in the form of rectangle. Now let us go back to the top view and number the points, the generators. 1, 2, 3, 4, 5, 6, 7. All the generators are to be numbered. I am always following a policy to number them in the anti-clockwise manner. Have some uniformity, don't number them arbitrarily. Naming should be always from the leftmost corner in the anti-clockwise manner. So in all your problems you don't have to think as from where to number them. So this is 1 dash, this is going to be 2 dash and 12 dash, 3 dash and 11 dash. Once you practice these problems, then you know the associativity of these as who is going to coincide with whom. 4 and 10, 5 and 9, 6 and 8 and 7. I am numbering or naming the corners of the square as P dash, Q dash, R dash and S dash. Now my job is to show these 12 generators on the development. Development right now is simply a rectangle, blank rectangle, whereas I am required to draw these generators 1, 2, 3, 4, etc., so that it will be possible for me to transfer the points. So front view right now is appearing in this manner with all the names and numbering. Top view still is a circle. No further details are shown in the top view. So let us now proceed to divide that particular rectangle, its length, into 12 parts. It was very odd distance, 188.5, and so we require a construction to divide it into 12 parts. Choose arbitrarily some angle and draw one line. Even this angle need not be the one which is measured as such. I am not saying 15 degrees, 20 degrees, it could be any angle. Take some distance in the compass, or if you don't want to use the compass, then you can straight away align the drafter, which is very well possible in this case. Align the drafter to this line that you have drawn, and you can straight away mark the points separated by a distance 1 centimeter. You are required to mark 12 such points. I am eliminating the use of the compass whenever possible, because that will increase the speed for solving the problem. To place the point of the compass accurately itself is a troublesome job. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This last point that we have marked, that should be connected to the end that should be connected to the end. This is still the construction only, and then fix the drafter to that line and go on drawing the lines parallel to the first line. You will ultimately get the length 188.5 divided into 12 parts. So the construction is to be shown in the exam. Don't take the distances directly. And now draw all those 12 generators. None of this generator is going to be darkened at any time, because these are not the edges of the surface of that cylinder. As nothing is mentioned, I will try to open it from the leftmost point, that is 1, and I will number these generators as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and of course 1. Now we are required to transfer the points. Let us transfer the points first of all from the section plane, and you will find that the section plane is cutting the generator 1, 2, 12, 3, 11, 4, 10, 5, 9 and there is some point from the top surface, whereas this square is cutting generator 4, 10, it is cutting 3, 11, 5, 9 and position P and R are placed on the surface of the cylinder from where no generator is passing. So probably I am required to construct the generator for P and R and as well as generator for this point of the top. Let me call it as point T dash. So these generators will be required, otherwise we cannot complete the development. So to mark these generators, you are required to simply take these points down to the top view. So point R dash, draw the projector, point P dash, draw the projector corresponding to it, and even point T dash, draw the projector. And so you can mark these points. We will have generator T between 5, 6 and 9, 8. We also have generator R in the same portion. So generator R is also there. and generator P between 11 and 12 and 2 and 3. Now these generators which we are marking in the top view, that is on the surface of the circle, we are marking these generators. You can see them clearly now. It is generator P marked between 11, 12 and 2, 3. Then generator T and R are marked between 5, 6 and 8, 9. Now these distances are to be taken, that is from 6 towards R. We can approximate this arc length as a straight line and mark it from 6 towards 5 on the development. Similarly, measure or take the distance in the compass 6T and mark it from 6 towards 5 to get the generator T on the development. So this job is now to be completed, so that all the generators will be present on the development. So one by one transfer all the generators, the new generators which we have drawn. So it is distance T, distance 6R is taken, and from generator 6 towards 5 R generator is marked. Similarly, the same is the distance from 8 towards 9. So generator R has been shown on the development. Then generator T, take the distance 6T in the compass, and from 6 towards 5 mark it, and from 8 towards 9 it will be the same distance. And to mark generator P, take the distance from 3 towards 2, it is the distance. So from 3 towards 2 we get generator P, and from 11 towards 12 we will get generator P. Name these generators. So this will be generator R, T. This is R and T. This will be generator P and P. Of course, those generators are to be drawn fully. So now we have got all the key points on the development. All the key generators are there on the development, and now we will proceed with transferring the points one by one. First, the section plane. Generator 1 is cut at this point, and so that point should be transferred using the drafter. So you get point 1, point on generator 1. Then point on generator 2 and 12. So it is point on generator 2 and 12. So we get a point on generator 2, point on generator 12. Then point on generator 3 and 11. Point on generator 3 and point on generator 11. Point on generator 4 and 10. Point on generator 4 and generator 10. Then generator 5 and 9. So generator 5 and generator 9. And then we get point T. We already have generator for T. And then the portion between T to T of the top is present. So that can be shown by the full life. Now this has to be joined by a smooth curve, for which you require either a practice or you will be using the French curve. The curve is to be drawn. And same curve on the other side also. And then generator 1 can be completed. So what we have got just now is the development of the cylinder if it is cut only by the section plane, the auxiliary inclined plane. The job still remains for transferring the points of the square. So let us transfer the points one by one. I am transferring points P and R to be marked on the generator for P, on the generator for R, again for R, and then that of P. Then points on generator 3 and 11, which will be obviously points on 5 and 9 due to the symmetry. So you can draw a line, that is the height. There are 2 points on each one of them. So the points are to be marked on generator 3, 2 points. Then on generator 5, 2 points. On generator 9, 2 points, and on generator 11, 2 points. And then after that we are required to mark point S on generator 4 and 10, and similarly point Q on generator 4 and 10. So these points can now be marked on the respective generators, and this is how that square is going to appear on the development, which is to be drawn by the curve. Don't join them by straight line. The surface under consideration is a curved surface, so we will be joining them by the curve. If you want, you can name the points. This was point Q, R, S. So this is again P, Q, R, S. T point should be explicitly shown. And we get the development of the cylinder, which has got a square hole perpendicular to its axis, whose faces are equally inclined to HP, and cut by some section plane which is making 30 degrees. What remains now is the dimensioning part. So let us see this development fully.